YouTube, I've put my old clothes back on because it's going to be another proper old school repair video. What have we got here? We have got another Acorn A3000. This one was much better wrapped than the last one. The last one looked like it had bounced its way here. That's one I did quite a while ago. I wanted to do another one of these because the last one was such a terrible video. So we're going to do this one. This one, the case doesn't look particularly well connected here, but let's have a look inside. Okay, so just looking around the back, it looks like the case actually in worse condition than the other one. It should have a tab there and a tab there. That tab is obviously broken off. You can see there should be a tab there, there should be a tab there, there should be a tab there, they've all smashed off. There should be a tab there, that's smashed off. Someone's cut the battery off here, but too late. You can see the amount of damage that's been done. Ooh, all of that blue stuff, all of this blue stuff is basically where the you know, the chemical, the alkali in the battery has reacted with the metal, and that's the colour it goes. It goes like this blue stuff. You can see it's got all into this socket here, this socket here, this socket here, this socket here, because what happens is it actually turns into a gas, and then the gas can move around, and when it settles on things it attacks them. So it's not, it typically will be localised, but it can spread pretty far. In this particular case it looks about as bad as the last one I did. You can see it spread into the keyboard ribbon here. This is the CMOS chip, that's completely covered in it. This is a crystal, I believe, for the real-time clock, that's completely had it. This chip has completely had it. These jumpers are going to need work. This mouse connector is going to need taking off and rinsing out in vinegar. The inside of the case doesn't look too bad. It's just a shame that it had lost those tabs that are supposed to clip under here. I might be able to 3D print something and epoxy it on to the top half. I don't know yet. We'll see. So just the ribbon connector pushes in, and I'm going to go easy. I'm not going to do this on camera because I want to do it right. Grab it both sides and then you put it out. The problem with this is I don't know how much of that battery acid has got onto the connector, so I'm going to have a look at that. I might just soak it with something first. I'll have a go and come back. Yeah, I should have really soaked that with something. That was the first one. I just pulled it out. You can see it's pulled all of the contacts off because it's basically rotted onto those connectors. So what I'm going to do, I don't know if it's going to be able to salvage it. I'm going to have to rebuild this somehow. But before I pull that one, I'm going to soak it in something. So I mean, what I'm doing here, I've got my anti-static brush and I'm just dipping it into, that's actually white wine vinegar, believe it or not. It says do not drink or do not eat. So yeah, I'm just pouring bits of that onto the board here, and then using the anti-static brush. Might as well get it started to destroy the acid, or the alkali actually. You can see that as I'm doing it, it's fizzing up. And it's fizzing up because it's basically neutralizing the acid. Okay, so as you can see I've got that out, but it's taken some of the graphite or whatever it is with it. I'm going to have to patch that up with some conductive paint or something. You can see I've cleaned it up there quite considerable. That had some tape on it that I've taken off, which is probably soaked with battery acid. Gone over it, gone up to about here, roughly, a little bit here, down over to about here, just with the vinegar. First thing I'm going to do is take the drive out here. There's 4 screws underneath, just one ribbon cable and power. Then I'm going to disconnect the power to the main power supply, and I'll probably just check that's putting out 5 volts, not on the scope but on the multimeter just quickly. Obviously got to disconnect the earth as well here. I don't know how this comes apart, I'm going to fiddle around with that in a minute. I'm just going to take these off. These only come off one way. Well, they should only come off one way like that, they shouldn't take that with them. So pretty dire appears to have happened to the reset switch as well. I'm not going to force it, but it doesn't want to move, so that could be a delight that awaits us here. I've just taken the power of the ground off there. Disconnect the earth here, and that's just going to put out of there like that. And then we just got the one screw here, one screw here. Yeah, there was another screw. It was hiding behind this this indescribably lovely sort of I don't know what the hell that is. Look at that. Have you ever seen anything like that? Okay, so you can see I've got that off. There's quite a lot of oxidisation still on there. I'm now just going over the whole board. The ye olde surgical spirit, otherwise known as isopropanol alcohol, and a anti-static brush, the whole board, to basically get the vinegar off so it doesn't sit there overnight. Okay, so there it is. First go over with isoprop, a lot better. And a couple of things I've noticed here. This is obviously rotten. That's a 0 ohm resistor, that's gone. This looks a lot better, but this is quite insidious. At first glance you might think, oh yeah, it's not too bad, but when you actually get involved with it, you can see how bad some of these traces have been attacked. So what I normally do, or what I did on the last one, is I take absolutely everything off of this section of the board. I then trace it through line by line and I repair as I go. You can see it's actually started to eat through here. It's eating through here. It started coming through here. Started coming through here. So I'm going to arrest that as well. You can see this is the approach I'm taking. These are some jumpers I put in vinegar. You can see the colour, it's gone green. And that's all of the crud, the battery acid being rinsed out. So I'll leave that for a while. And then the chips, the ROM chips, which were right next to the battery acid, and this chip here, which is pretty close as well, just the legs having a little soak up in some white vinegar, and another little isoprop bath. Okay, so I've cleaned up the chips with a little bit of sandpaper, the ones that are rough. So they're actually not that bad, and I've labelled them so I don't get them the wrong way around. So it's the next day now. I'm going to take off these sockets, this connector, these this connector here, this chip, these chips, this chip, the crystal, all of these resistors and capacitors. I'm not going to show you me doing that because I've only got two hands, but I will show you me repairing the traces once I've got them off. Okay, this is a bit of a part way because I've now got a bit fed up with it. I've managed to get these sockets off, 3 of them. I've managed to get the keyboard connectors off. That's what they're like underneath. Absolute hideous garbage. This will not come off very easily. For some reason they've used a turn pin there. These were all normal dual white, but less metal and less tight. So I'm going to have to really carefully go at this, you know, go at the edges, dissolve as much as I can, and then gently pry it out. I have actually desoldered underneath all of these as well, but they're not coming through. This is being an absolute pig as usual. Okay, so another little rest. These 0 ohm resistors are disintegrating as soon as I touch them, so they're going to need to be replaced. I finally got this off. Absolute nightmare. Haven't damaged anything so far. I'm going to go up to here and here and leave that for a minute. This will just not come off at all. 3rd attempt so far. I ended up having to cut this one off. I basically cut the socket in half. One half came up, the other one wouldn't. It was a turn pin. I don't know why it was so tight in there, but that was bloody awful. But that leaves pretty much all these lanes clear once this is off, to see what we got to repair. You can see there's quite a bit of damage there, which is where the battery was. But the damage does go further than you might think. I mean, there's damage up coming onto this chip, even little bits. Quite a bit of damage under that socket that didn't want to come off. A lot of these lines are going to need replacing or repatching. Took this switch off, it's jammed, I don't know why. I'm going to have to take that apart and see what's happened there. And then the chips, they've been in the vinegar for a couple of minutes, and now they're just having a little babe in some isoprop and clean them up. So it's the next day now. These have been sitting in a bath of white wine vinegar, which is probably not the right kind of vinegar. I've ordered some white vinegar, but this was white wine vinegar. As you can see, it's still dull, but the green has gone. You see the colour that was green has gone kind of like orange. So I will give those another go with white vinegar as opposed to white wine vinegar and then isoprop. But looks like we got these back. some of the sockets not so great. The greens come off them, but yeah, that's not going to be very good. So the first thing I'm going to do, when I've got it all clear like that, is just spray it with some white vinegar. Put that all over the board here and rub it in with a cloth. So then I'll just wipe the excess off of the cloth. So just rubbing the surgical spirit in with a brush. Word to the wise, don't use surgical spirit near your soldering iron. You saw earlier it can tip over and it is highly flammable. If you've got your soldering station on and this tips over, you'll be in serious trouble. So I'm just going to get that worked into the board here. Come back in a minute. Okay, so I've finished removing components. It's got you balanced on top of a paint can here. Paint can cam. And you can see how bad these traces are. They're green, they're nasty. That's where the crystal was. Come over a bit further. You can see here, for example, how bad they are. Going up to, I think that's the mouse connector. You can see how bad they are. How bad they are. Coming all the way up to the keyboard connector. Gonna need some serious work. What I'm using is a fine pin, basically a scraper, a needle scraper, and I'm just going to literally start taking the solder mask off of each trace like that, and following it all the way along. I'm just basically scraping away the solder mask off the top of each of the tracks, and you can see I have gone over all the traces. These ones where I've just scratched the top off, whether they were black or green, most of them were. I'll try and show you the rest here. So you can see these original, or rather, these original, and these are where I've scratched them off. And there's a hell of a lot of damage, a lot more damage than there was on the other board. All under the ROMs. Some of these lines are broken, see here, it disappears. Here it disappears, here it disappears. So I'm going to have to put some wire in there and make that good. See how extensive the damage can get on these boards. Obviously I've missed a bit there, I've got to go back and do that. That's what I'm trying to get there. It's that black colour, so you can see these are what I've stripped back. That's what I've stripped back. That's what it should normally look like. I've lost the black one there. Oh, there's the black one. So that is what they were looking like. So basically the corrosion's got underneath and it's killing it slowly. But yeah, these are all now cleaned. So what I'm going to do now is I'm going to get some solder and some flux, fine tip. I'll show you me doing one or two of them. I'm not going to bore you with all of them. Just going to coat them up with solder and then I'm going to check continuity. So I'm going to try and show you me doing a couple of these and then I'm going to get on with it. But basically flux pen goes along here. Got to have flux. If you haven't got flux, you will be fluxed. I'm going to try and quickly show you this. It's difficult to do it for a camera and I'm not going to do it all for a camera. Just get a little bit of solder on the end of the iron. I'm going to pick a trace, say this one, and I'm just going to thicken it up with a solder like that. Don't stay on it too long and I'll come back in a minute. So you're on paint can cam again, and what you can see here is where I've patched up the traces with solder. Like I showed you, scrape them off and then patch them up. There are millions and millions and millions and millions of parts of damage. You can see all over the place here and here and here and here and all of that. That's the wire I'm going to use to patch up any that don't work. That's out of a transformer coil. Just get that out of the way, and then so all those patched, all those patched. And then when it got really bad, the corrosion, it wouldn't take. I was going to buzz over this with a Dremel, but A, noisy, B, I want to keep as much of the solder mask as I can, so I didn't do that. So I can't shoot this live because I just ain't set up for it, but I'm just show you here how I'm doing this. That's the wire from the transformer coil, held on with a bit of blue tack. And what I'm doing is I'm just literally looping it through one side and then tagging it. So you can see I've done these two. 1, 2. This one's next. I've done this one as well. And it's just literally going to be that. I'm hoping this core is, when it's flattened out, it will be the same, or able to carry the current. I'm pretty sure it should. This is a magnet wire, and I've used it to basically follow the traces. And you can see the extent of it. It's absolutely rotten, and hopefully that should work. It's insulated, so I've got to be very careful when I put the sockets back on. You can see the damage has come all the way up to here, all the way over there. I'll scoop it out a bit. So yeah, all the way up to here, up to there's where I stripped it. Even done a little bit of work over here. See, I've tagged it there. All the ROMs, this side of the ROMs were really bad, and I just had to literally rebuild those tracks. It's a painful process, just sticking them down, tagging them to what's left of the track. Trying to make them good. That's the clock circuit, the crystal. That's the resistor leg, because there was nothing left in that hole. Like there, not particularly great, but there was nothing left in that hole, so I had to do that. And then over on the ROM side of things, you can see that they were pretty shocking as well. Made a little eyelet there. Oh, where is it? There. Hopefully that will work. You can still see there's still damage there. That's what they're like underneath, rusty and rotten. Won't take solder, a lot of them. Basically up to about here, down to about there, definitely got to be sorted. Scoot you in. That's what you're getting into if you get one of these machines. For crying out loud, if you've got one of these machines, take the battery out, cut it out, and then wash it out in vinegar. Otherwise it will die. So the silver is where I've patched it out with solder. The copper is where I've laid a new trace on top of the old one, and the yellow, like that, is the original. You can see where I've patched it up with the silver, all those tiny little bits. They're all damaged. I'll put that chip back on for now. Coming down to here, you can see there as well, lots of damage, patched up. And you can see where the ROMs were, how bad they were. And that's patched up with a mix of solder and wire. I've unblocked some of those holes, but certainly getting there. Coming up here. Coming up here, damage that's been patched up here, all the way up to here has been patched up. I'm getting up towards the I/O chip. You can see I've even patched up all around the I/O chip. That was damaged as well. Not only there, but around the back was all damaged. That side wasn't so bad apart from the bottom there. And all that side I've patched up as well. All these resistors, patched those up. I've just noticed I've got to go back over that bit. Getting to the point now of putting some components back on. You can see I've put some lacquer on that, and then put the crystal back on, put the clock chip back on. This is the next chip that's going back on. Here, you see I've run wires, or thicken the traces up there. And you can see here, that one actually needs redoing again. You see I'm tagging it to each part where I can of the existing track. Sometimes there's not enough track to stick it to, and that's why there it's come off, but most of the time it has actually stayed where it should. So what I'll do when I get back to that stage, I'll just use some conformal coating or something just to hold it in place. These resistors I'm going to leave, they're slightly out of spec. They're supposed to be 160 ohms, they're measuring 190, but they're not too in the way. That one's under a bit of a heat shrink because that track goes underneath that resistor, that surface mount, and so what I've done is I've just put a bit of heat shrink over it and jumped it over the top as a bridge. But I might end up taking those off depending if they work or not. But yeah, so next is to get this guy on. Little part way update, I've got some of the links back on there. I'm just going to bite the bullet and start socketing the chips. And you can see underneath the links the wires there. And tracing them all out as I go. Painful process. So it's another little partway update here. Got the sockets on for the ROMs, I've buzzed them all out. So they're all on. I'm going to buzz them all out again just to make sure I haven't shorted anything because some of those pins were very tight. And some of the tracks between the pins had to be recovered in solder, so I'll check that. And now I'm going to buzz out all of this section, which is going to be pretty tight. Before I start getting those sockets on. So I've had enough for tonight, but it's a quick update where we are. I've got this on, all the ROMs on, one of the decoders for the keyboard there, and the reason it's taking so long is when I'm looking at it under the microscope I'm finding traces I've got to reinforce, because if I don't they're just going to burn out as soon as I put any current through them because they're rusted away. So got on that for now. I've checked it's not bridged and it's still making continuity. And then moving up here, I've got that socket on. All of this has now been buzzed out. It's just a question of carefully putting the sockets on, and where I see anything that I'm not happy with, just making sure, because I'm sure as hell I'm not going back and doing this again. It's before and after. This is obviously after. All the sockets back on, all the components are back on, looking a lot better than it was. Checked, buzzed out pretty much all the tracks, but what I want to do before I plug it in is just, now this is on, buzz that out, make sure there's no shorts, because there are wires like this running in between those pins, so I just want to check that. I've done all the others. Can't really see them underneath the chips there, but there are magnet wires running along underneath, certainly these two, a couple of these. So I just need to finish it off here. You can see I have to do a lot of repair. I just used solder on the bottom there. It wasn't so bad. But for example, you can see here, that's an example of the wire coming through the bottom to join up the two sides of the board. So I'm just checking the 7.4 logic here. You can use an eprom program and a test function. So one at a time, just testing, are they okay? The only thing it's missing is the reset switch. The reset switch had nothing inside it, it had been glued back together and wasn't doing anything anyway, so I figure if it was working without that reset switch working, it should work now. Okay, so I've put it back together, put the keyboard in for now, plugged it in. That's the other Archimedes just for comparison. Now I've fired it up, and what do I get? I get something, so it's working, and I get an address exception. Now I do know, doing a little bit of digging around, that one of the address lines on the ROM is shorted to ground. However, I can still type on the keyboard. Not all the keys work because the connector's not very good, but I've got something at least. The other thing I'm getting is a code on the floppy drive light that's telling me that there is a ROM checksum error. So I've traced out, when I traced out the pins before, I know that the second one from the left on the bottom of that first chip is shorted to ground, and it shouldn't be because it isn't on the other Archimedes. Just rebooted it again. The other interesting thing is that each key I press gives me 2 of everything, so I've obviously screwed something up there, but looking a bit more hopeful now. Okay, so because the keyboard connectors are so corroded, what they're doing is when I pull the ribbon out, they're actually pulling the graphite off the connector. I've already cut 3mm off that connector. I can't afford to keep putting it back in and out. It's probably got one last chance. So what I'm doing at the moment is I've hooked up a momentary switch to what I've traced out on the membrane of the keyboard what the delete key is. And what it is 6 from the bottom one from that side and 11 from the top one from that side. So if you never need to do that, then that's how you do it. Okay, so yeah, just to explain that, what I did was just traced up to there. So I worked out which is the delete button, and I think it's that one, and then I followed these tracks all the way along on that side to that one, and then flipped it around and did the same thing and followed it to that side, and that's how I worked out which one was the delete button to hold down. So it's turned off, turn it on, hold my little button, we get that, which means yeah, we're booting. We get the supervisor, so the memories are working, RISC OS free, blah blah blah, and there we go. So another Archimedes rescue from the scrap heap. Hopefully these wires will keep it going for some time. There's a bit of redundancy built in there, in that if the trace goes underneath it, it's backed up. The other thing that gone that was throwing me was this little clock chip. When I first did this and pressed the reset button, it started cutting out in the picture, and I thought, oh no, I've flexed the board, something's gone wrong. Another little thing to watch is these jumpers. I had them set wrong. I had them set long ways, which threw me for ages on the green ones. They should be across, not up. Stupid mistake, easy to do. But there we are. That is the Archimedes now up and running. The other little things to watch out for are these two jumpers here. And just for posterity, that is the position they're in. And these two jumpers here, that is the position they're in. That will make it pick up on a TV, on a composite. Without that, it's getting no signal. So I hope you enjoyed that. I hope that was entertaining, and another one rescued. And I will continue with this repair in the next video, but that will be a while away because I've got to wait for these connectors, and got to fix up the case, got to sort out the battery mod, going to sort out the power supply. But for now, thanks for watching. I'll see you later. Cheers.